So today we're going to do section 3.8, which is derivatives of the inverse trig functions. And again, we've got this list of trig derivatives that we have to memorize. So the trig derivatives are from section 3.5. These are your inverse trig derivatives. And again, memorize, memorize, memorize. They show up everywhere on the AP exam. So the first one is inverse sine of x, and it's 1 over the square root of 1 minus x squared. You do not have to memorize this part. And then inverse tangent is 1 over 1 plus x squared. And then inverse secant is 1 over absolute value of x times the square root of x squared minus 1. Notice that the co-functions, all the c functions, exactly the same, just with a negative out front. So again, you're only memorizing 3. A couple little tricks that help me remember some of these. I remember sine and secant start with s, and so does subtraction. So that's how I remember that there's a subtract on the bottom. Tangent starts with a t, which looks like a plus sign, so that's how I remember there's a plus down there. These are just my tricks. And then the one with the absolute value, that secant, I just remember secant's complicated, so it has the complicated derivative. And I always remember that the x's have to be next to each other. So it's absolute value of x next to the square root of x squared. That's how I remember this one. The x comes second. This one, the x comes first. So just a couple of hints to help you out with memorizing those. For those of you who don't have an TI Inspire or a fancy calculator, you cannot hit secant, inverse cotangent, or inverse cosecant. We don't have a button for those on our calculators. So just so you know, these are the calculator conversion identities. So if you ever have to calculate an inverse secant value, this is how you do it. These are not something you necessarily have to memorize, and these are also not derivatives. So just making sure you know if you need to calculate one, that's how you do it. So example 1. All of our same derivative rules and tricks apply. It's just that we have all 6 of these new derivatives up here. So the first one says, let's do the derivative of inverse sine of x squared. Now, if it helps, put those parentheses around there. So what you should notice is that you have a function inside of a function. So this is a chain rule question. So I know I have an outside function and an inside function. So my inside function is x squared. My outside function is inverse sine of u. And like I said, I do my shortcut. So the derivative of u with respect to x is 2x. And then the derivative of inverse sine of u is 1 over the square root of 1 minus u squared. And I got that from right up here. And then as with any other chain rule, what do we do with these two? We multiply them. So we get 2x times 1 over square root of 1 minus u, which was x squared, squared. So when we put it all together, we get a 2x on top and a square root of 1 minus x to the 4th on the bottom. And that's your derivative. So then example 2 says now we've got this particle moving along the x-axis so that its position at time greater than or equal to 0, so time is positive, is x of t equals inverse tangent of square root of t. Once again, you can kind of imagine some parentheses there. We have a chain rule again. And they want to know what is the velocity at time 16. So again, chain rule. Our inside function is square root of t. And then our outside function, and I guess we should call this x, so that we're sticking with the variables that they gave us. And we get inverse tangent of u. Now, square root of t, we haven't talked much about this one. That's the same thing as t to the 1/2 power. That's a lot easier to find the derivative of. So now when I do the derivative of t to the 1/2 power, we bring the 1/2 down and we subtract 1. Now, what does a negative exponent mean? Bring it down to the bottom, and that 1/2 power is a square root. So we end up getting 1 over 2 square root of t. The derivative of inverse tangent of u, inverse tangent was 1 over 1 plus x squared, so with the u, 1 over 1 plus u squared. And with chain rule, we multiply these two derivatives together. So 1 over 2 square root of t times 1 over 1 plus u, which was square root of t, squared. So when we put all of this together, 1 times 1 is 1. And then I get 2 square roots of t times 1. Square root of t squared is just t times 2 square roots of t. So we get 2t square root of t. And now we plug in 16. So go ahead and plug in 16. And you get 1 over 136 feet per second. So there's our velocity. Next one, I want you to try on your own. Same process. All right, so I did derivative of the inside, and I got 20x cubed. Derivative of the outside is 1 over absolute value of u, square root of u squared minus 1. So when I plug everything in, that's what we end up getting. Now, a couple of things that I want you to notice. Absolute value of 5x to the fourth. 5x to the fourth can never be negative, so the absolute values aren't super necessary here, which means we can simplify here. So 20 divided by 5 is 4, and then the x cubed with the x to the fourth down here means I'm going to leave the absolute value of x down here. And then in parentheses, or sorry, in the square root, 5x to the fourth squared gives me 25x to the eighth minus 1. So there is our derivative. Last but not least, example 4. There's those magical words. It says find the equation for the line tangent. What are the two things that you have to identify right away when you see this? We need to have a point and a slope. So they've started to give me a point. So cotangent, inverse cotangent of x at -1. -1, comma, we don't know. We have to do inverse cotangent of -1. But we don't have an inverse cotangent button, so that's where you have to go back to those identities. And so we have to do pi halves minus inverse tangent of -1. And when you put that into your calculator, I believe you get 2.36, something like that. So the only thing we still need is the slope. And to find the slope, we have to do the derivative. So the derivative of cotangent is -1 over 1 plus x squared. And they said at -1. So if I plug in -1, we get -1 over 1 plus 1. So we get -1/2. So then the equation for my tangent line, y minus 2.36 equals -1/2 x plus 1. Ta-da!